So hello everyone, and it's 6:15 p.m. So I'll say let's get started, and I'd like to welcome to the Learnathon both the people that are online. So thank you for participating online, and also our on-site attendees. Thank you for coming to this Learnathon. My name is Roberto. I'm a data scientist on the evangelism team at KNIME, and today together with me there is Lada. How do you want to introduce yourself?
Yeah, I'm a data scientist at the education team at KNIME.
Yeah, and together today we're gonna walk you through this Learnathon. It's a hands-on session, so I'm happy that I see you all with your laptops here on site, and we're gonna build some workflows. What is this Learnathon going to be about? Okay, so we're gonna be detecting frauds in contracts, and then we're gonna leverage GenAI to create custom alert messages for customers or for clients for which there is a suspicious activity, and in a way to alert them. Okay, so we're gonna have a section where we have a data preprocessing and fraud detection, and then the following section is about really using GenAI in one way is a simple approach. So we just prompt the model with a simple prompt, and a more complex, let's say, step, we're going to use vector stores and user-defined knowledge base to enrich the response of the model. We're going to use a low-code approach with KNIME, and the end result should be you would see it's not very visible right now, I guess, but you will have to create this little email alert to send to customers. Mine is an example. So obviously there are some stretches in terms of how plausible the example could be in a super real scenario. But hopefully you will learn what I think so too about how to use GenAI to enrich your data analytics processes. Okay, with that, I leave the stage to Lada, and I'll be back for later.
Okay, thank you, Roberto. I hope everyone can hear me well. If not, please let me know. So I will walk you through the KNIME Analytics Platform. I will give you a brief intro to KNIME Analytics Platform and brief intro to the fraud detection problem. And then I'll give over again to Roberto so that he can tell you how to implement GenAI in KNIME Analytics Platform without coding. So let's start with a brief intro to KNIME Analytics Platform. What is KNIME Analytics Platform? KNIME Analytics Platform is a open source and free low-code tool to make sense of your data. So what does it mean, make sense of your data? You can apply it in any application, data engineering, data science, data analysis, for different tasks like transformation of your data, moving your data from one source to another, visualization, reporting, built-in machine learning models, and many more. What does low-code mean? KNIME Analytics Platform is using visual programming paradigm. That means that in KNIME Analytics Platform, you build your projects as workflows. So this visual workflows that you can see on the bottom here, they consist of so-called nodes. Each node performs a particular task on the data, and you build these nodes and connect them one by one, and then you have your visual process of how your data flows from A to B. So each node has either input or output or both, or multiple inputs, outputs, and it has a name, so you can see which task it performs on your data, and it also has a status. And we will talk about status a bit later. KNIME software in general covers the whole data science lifecycle from creation to production. So we have two parts of the software. KNIME Analytics Platform allows you to prepare and build your data solutions, and KNIME Hub allows you to then deploy them in production. KNIME Analytics Platform has around 4,000 nodes for different tasks that you can perform on your data. You don't have to learn all of them, obviously. You just need to find the ones that can help you solve your problem. Let's just have a brief overview of what nodes we have there. So for example, KNIME Analytics Platform has the nodes to access your data from different sources, different file formats, from simple ones like CSV, Excel, and so on and so forth, to more advanced file formats such as images, audio, text, networks. Of course, there is a connectivity to databases. to SQL databases and to NoSQL databases, and also there are connectors to other resources, and you can also send REST requests to sources to which we don't have a particular connectors. Also, big data connectivity is supported, so you can process your data in Spark, for example, by using the resources of the Spark cluster, but at the same time controlling the whole flow from within KNIME. You can connect to HDFS, Hive, Impala, and also use these computation resources. There is a broad range of nodes to transform your data, for example, to clean your data, merge, aggregate, and so on and so forth. There are nodes to analyze your data and build machine learning models, again, from the most classic machine learning models, such as regression, classification, and clustering, to more advanced integrations, for example, to build deep learning models with Keras or TensorFlow, and also you can integrate other open source tools. And of course, you can do cross-validation, parameter optimization, and scoring of your models. Another set of nodes allows you to visualize your data in interactive visualizations and build also the dashboards that contain more than one visualizations. And again, we have more simple visualizations, classic visualizations as box plot, line plot, scatter plot, but also you can visualize word clouds, do geospatial visualizations, molecules, and more specialized visualizations. And finally, there is a set of nodes to deploy your work that you've done in KNIME. And this could be something super simple, like just saving to another location, or preparing a report, or actually deploying your workflow, let's say, as a REST API service. Okay, so that was a brief overview of what nodes, which nodes are available. So how do you actually install KNIME Analytics Platform? KNIME Analytics Platform is a desktop program that you can download from our website and just select the package that fits your machine and then install it on your machine. And then once you installed it, you will have, once you want to open KNIME Analytics Platform and actually work in it, you will need to select so-called KNIME Workspace. This is basically a folder on your local computer in which you will work in a current session that you open when you open KNIME. Okay, so let's have a quick look at how KNIME Analytics Platform looks. Once you installed it and opened it, this is the first page that you will see. I hope you can see. And here you will see some example workflows, or what's probably more important, you will see your local space. This is your local space, and this is the place where you will actually create and modify your workflows. And here you can create a new workflow. And let's say once you opened one workflow, you will have this new tab open here, and this tab basically indicates the workflow that you are currently working in. Here you have the workflow editor, and this is the place where you create and update your workflow. And we can talk about Node Monitor a bit later. What's more important now is that you have here the 4 tabs that can help you navigate through KNIME Analytics Platform. The first tab here is the description tab that shows you the description of, for example, here you can see a node is selected, and on the left then you can see the description or documentation of this node. If you click on somewhere on the workflow, you will see the description of the whole workflow. So here you basically can find some additional information, some documentation. Another tab here is called Space Explorer, and it allows you to navigate through your workspace and switch between different workflows, also navigate to the data files, and basically browse through your workspace. The next tab is called Node Repository tab, and this tab contains all the nodes that you can use to build your workflows and all the nodes that are already installed together with your KNIME Analytics Platform or from additional extensions. And from here, you can drag and drop them to your workflow and actually use them in your workflow. So how does it work? You just select a node that you think is that you think can solve your task, and you drag it from the node repository and drop it in your workflow. And then you would also need to connect two nodes, and you just drag the connection between the nodes. Okay, so I briefly mentioned that each node has status, and there are different statuses that a node can have. For example, you can have not configured status. So basically, once you drag a new node from a node repository to your workflow, you haven't configured it yet. What does it mean? You haven't provided any parameters to it so that it knows how to execute its task on your data. So this is then the status that you will see, basically a warning that you need to configure the node. Once you configured your node, you will have this yellow traffic light, meaning that the node is ready to be executed. And then once you executed it, you will have the green traffic light in case everything succeeded, or the arrow in case something failed. So Node Monitor is a useful tool that you will also see if you click on any of the nodes that provide some output. For example, this node, you can see it has two output ports. So in the Node Monitor, you can see two tabs that provide the overview of the table that you can then find in the output of this node. And this Node Monitor shows you the dimension of the table, of the output table. For each column, it shows column name and type. And you can also search and filter in this table, and the missing values will be shown as red question marks. And also, so this was a table mode. If you can see here, you can also switch to the statistics mode that will show you the overview of your output table. Okay, then I already mentioned that there are nodes that can help you to build interactive visualizations, and those nodes are usually of blue color. We call them view nodes, and these nodes have this option here to a magnifying glass to open the visualization that you created. And then once you open it, the new window will open and you can interact with this visualization. So you are working in KNIME Analytics Platform, creating some workflows there, and they are saved in your local workspace. But let's say if you want to share your workflow with someone, it might make sense to export them from your local workspace. And for that, we have two special file extensions. The first one is for single workflow, and the second one is for a group of workflows. So how to export the workflow? Let's first look at this right part of the slide. You just navigate to a workflow or workflow group that you want to export, right-click and click export, and then it will ask you where you want to export it. And then you can share this file with someone. And other way around, if you want to import a workflow, you can click this three dots and then click import workflow or add files. Additionally to KNIME Analytics Platform, we have a KNIME Community Hub that you can access from a web browser. And this is the place where you can search all the nodes that are available, additional extensions for additional functionality, and also example workflows that KNIME Community shares. And there you can also store your workflows, and you can also version them. I already mentioned KNIME extensions. So basically, it's a set of nodes that provide you with some additional functionality. When you just install KNIME Analytics Platform, it will have some core set of nodes, but there are many more extensions that you can install to access additional functionality. And you can do that by going to menu, install extensions, and then just searching the extension that you would like to install. And finally, there is a KNIME AI Assistant in KNIME Analytics Platform that we call in short KI. How do we call it? Kai. We call it Kai. Yeah, and it has two modes. It has a question and answer mode, so basically a chatbot. You can ask it, how do I perform a particular task, and it can provide you with some suggestions on which nodes to use, for example, and it will also provide the nodes already here, and you don't even have to go back to node repository. You can drag and drop them directly from here, or you can click this build mode and actually ask it to directly build a workflow for you. Okay. So that was a very brief overview to KNIME Analytics Platform. And let's also have a look at fraud detection problem, and then we can jump into an AI topic. So today we will work with an example where we will first process the data and detect fraud with a simple method for fraud detection. And later we will see how to enrich this whole fraud detection application with AI. So what is fraud? Actually, I think everyone probably knows fraud is a deceptive action to get some unlawful gain. And obviously it can impact individuals, or on a larger scale also industries, entities, services, and so on and so forth. There are different types of financial frauds, tax frauds, credit card frauds, and other frauds. And obviously, even if they happen rarely, they can have a large impact. So, of course, you would like to detect them as soon as possible. So in our example, we will talk about how to detect fake contracts. And in our example, they will be stored as PDF files. It will look approximately like this, such a contract. And we will try to find the outliers in this PDF contracts. So the contracts that significantly different from average contract. And we have some values in this contract, such as contract ID, amount of the contract, and the date. And we will particularly look at the amount of the contract that differs a lot than an average contract. So first we will get the data from different sources, from PDF contracts and also from client data on database, and then create one table with as much with all the information that we have about the contracts. And how can we actually then detect fraud? Well, of course, you can detect it manually, but this is not what we want to do here. Obviously, we want to use the data to detect fraud automatically. And this is often done with outlier detection methods. Outlier is a data point that is significantly different from other observations. For example, on this picture, you can see that we have different groups of data, and there is this one little point here that kind of doesn't belong to any of those groups, and in this case, this would be an outlier. And outlier detection techniques are often used for fraud detection. So what are the common techniques for outlier detection? For numeric data, you can build visualizations to analyze visually which data points don't fit into a general trend. You can use statistics methods. There are also more advanced methods. For example, you can apply clustering, machine learning methods, and deep learning methods to detect outliers in numeric data. And for nominal data, you can use string similarity metrics. So today we mostly want to focus on application of GenAI in the fraud detection application. So we will use the simplest methods, visualizations, and statistics. But obviously there are more advanced methods to detect outliers. Let's have a brief look at these techniques, and let's start with the visualization techniques. So there are many different ways how you can visually detect outliers. Today we will focus on just some of them. So we will check different visualizations to compare different categories of data, to check the correlation between them, distribution, and just visually detect the outliers. So if you want to compare different categories of data, You can build, for example, bar chart or pie chart, and a bar chart might be more useful if you have many categories to compare to. Pie chart might be better if you want to compare just two categories. If you have many more categories, it might not be that easy to compare these pieces of the pie chart. You can also build a scatter plot or bubble chart to see the correlation between two or three different numeric columns. For example, in a scatter plot, you can compare two columns, and then you can see which data points don't fit into general trend. With the bubble chart, you can add additional dimension by introducing the size of the bubble. You can also build a histogram or a violin plot to check the distribution of a single numeric column, for example, with the histogram. Then you can see which values are underrepresented in the column, or you can build a violin plot to check that for different categories of a numeric column. And finally, you can also build either box plot or scatter plot to, for example, in box plot, you can spot outliers for one numeric column. Box plot shows you the summary of the data, and so you can see which data points are significantly different from the data in general. And again, in a scatter plot, you can see which data points don't fit into a general trend. Of course, you don't have to choose just one visualization. You can build dashboard and have a look at different visualization. Actually, maybe double check that many visualizations provide the same results. In KNIME Analytics Platform, you can build a dashboard that consists of different visualizations by building the visualization separately in a separate view nodes, and then wrapping them into a component, and then just opening the view of the whole component. So should you use visualization techniques? There are advantages and disadvantages. They look nice, the visualizations. I think it's always a good idea to maybe start the analysis with a visualization, because you can get an idea about your data. And it might be that the outliers are easy to spot and interpret. But at the same time, you can only investigate one or two dimensions, or sometimes three dimensions at a time. And if you have more dimensions, it might be not that easy to spot the outliers. And then you still need to manually go through these visualizations. So there are, of course, the ways to automate this process. And the first option is to use statistics methods. And this is the only option that we will have a look at today. As I mentioned earlier, there are other options such as clustering, machine learning, and deep learning. But today we just have a brief look at this simple option to detect the outliers. And one technique is called interquartile range technique. And how does it work? So you select one column in which you want to detect the outliers and find the median of data that splits the data into a lower and upper half. So this would be, this is the box plot. This would be your median. And then you also find the third quartile and the first quartile. So the third quartile would be the median of upper half of your data, and the first quartile would be the median of lower part of your data, lower half of your data. Then you need to calculate the interquartile range and choose the parameter k. Interquartile range is the difference between your third quartile and first quartile, and parameter k you just need to choose yourself. You might run this several times to find the optimal parameter. The default parameter, for example, in KNIME Analytics Platform is 1.5. And then what will be your outlier? Your outlier will be the data point that lies above this value, third quartile plus k multiplied by interquartile range. And let me move this quickly. or if the data point lies below this value, first quartile minus k multiplied by interquartile range. Okay, so yeah, that would be the outlier. For example, this would be this maximum value that we calculate as this. And this would be then outlier because it lies above this maximum value. And let me move zoom again. And here would be another outlier if it lies below this minimum value. Okay, so a very simple technique. In KNIME Analytics Platform, you can calculate it by using the numeric outliers node. And here you would need to provide the column in which you want to find the outliers, the parameter k, and also, since we want to detect outliers, you would need to decide what you want to do with outliers. And in this case, you would need to remove the non-outlier rows. And another node that can help you visualize the same thing is the box plot. So the advantages and disadvantages of statistical techniques, they allow you to automate the outlier detection. They are quite easy to understand and very easy to implement in KNIME Analytics Platform. You just need 1 or 2 nodes. Well, there is a disadvantage that you might need to know some statistics. I'm not sure if it's a disadvantage if you want to detect outliers anyway. It allows you to detect only outliers in one column. So this might be a problem if you need to analyze multiple dimensions. And another technique that we didn't mention is zeta score technique. It assumes, for example, that your data is normally distributed, which is not always the case. And then what about multidimensional analysis? As I mentioned, there are other methods, advanced methods such as clustering, machine learning, and deep learning. They can also help you to detect outliers by looking at multiple dimensions. But today we will skip this part and jump into part everyone's probably interested in, which is Gen AI. And I'll, Roberto will take over from now.
Thanks, Lada. Okay. All right, let's continue with the part about Gen AI. Okay, first thing, let's remind ourselves where we are in the exercise that we're going to have to solve later today. So when Lada already explained how we're going to access and manipulate our data to then detect frauds visually and using statistical techniques. And in the second part of the workflow that you see, we're going to use, as I said, also the beginning Gen AI to prompt, so basically LLMs, and we're going to prompt the LLMs to create custom alert message to send to our customers. And in the second, more advanced, let's say, step, we're going to also use vector stores and knowledge bases to enrich the response of the model. Okay, right. Let's have a look. First of all, what are LLMs? LLMs in a nutshell. I'm confident that most of you have already heard about this topic. It's everywhere right now. But just in case somebody hasn't, let's bring everybody on the same page. LLMs stand for large language models. They are a very popular class at this point of deep learning networks. They are, in a way, revolutionizing the way we interact with technology. They are extremely proficient at the understanding, generating, and also simulating human conversational behavior. So that's why they are becoming extremely popular, because it's so easy to interact with them. LLMs can be of 2 different types, multi-purpose and multimodal. Multi-purpose refers to the fact that they can excel in different tasks. For example, text summarization, question answering, code generation. So they are not let's say, specialized uniquely on one task, but they can solve multiple. And multimodal means, on the other hand, that some LLMs can also be input with images, with videos, with audio files. So not only text, which is probably, let's say, the most common way to interact with them. And I'm sure you all have heard about some of the most popular examples from OpenAI, ChatGPT or GPT-4, Google's Bard, and Molly by Databricks, and so on. But why are they called large language model? Why is this large? Where is this large coming from? So to be fair, language model and large language model, at least we thought they were large language model, already emerged in 2018, when basically the architecture, the deep learning architecture of transformer became popular. But ever since, they've increased their size. By that I mean the number of trainable parameters and also their proficiency. In 2018, we were probably, most of us, using BERT. I don't know if you're familiar with it, but there was a very popular and sort of breakthrough in that specific moment. Now, the number of parameters that BERT has is probably makes us laugh compared to the size of current LLMs. And in fact, the adjective large refers to the billions of trainable parameters used by these models to learn and to be able to understand and generate text in a human-like fashion. And on the slide, you can see a little bit the evolution of basically how this model have grown in size. And in fact, there seems to be a trend that the larger the model, the better the performance. Doesn't have to be always the case, but it seems to be so far the case. And GPT-4, we don't have a super clear number about how many parameters the model has, but we're talking about roughly 1.76 trillion parameters, so it's huge. And it's already much, much bigger than GPT-3, which already performed extremely well. But how do LLM think? So basically, if you will have to explain in a very simple way how LLM think, you can think of it as a highly sophisticated auto-completion system, a little bit like what you have on your phone when you're typing a message and your phone is able to predict what is the most likely word that comes next. So it is a bit basically working the same way. So given a sequence of a string, text, the LLM needs to learn how to predict what is the next upcoming word. And in fact, they are trained to suggest the most likely next word or phrase based on the previous tokens or the previous string. And you see here an example. The sentence or the phrase "the sky is," the model has learned that based on the amount of text, the corpora text that is being exposed to, that the most likely word would be blue. So that it has the highest probability to be the next word, and therefore that's the word the model will be suggesting. And you can imagine that after the word blue is predicted, the model will continue and predict the next word, and so on. Now, how can we interact and customize our interaction with LLMs? We have broken down this interaction into 4 different steps, each basically building on top of the other. And these 4 steps, this 4 level of customization and interaction with LLM can be done in a low-code fashion with KNIME Analytics Platform. Let's start maybe from the most straightforward and probably the one that if you are using ChatGPT, maybe even on the browser, you are most used to use, which is prompt engineering. This is essentially crafting usually a string that is containing instructions to query basically your model. And in KNIME Analytics Platform, you can create a prompt, assemble a prompt using, for example, the string manipulation node. And we will see during hands-on session, you will have to actually build during the hands-on session some prompts. And we can, in fact, one of the biggest advantage of using this approach is that you can parameterize your prompt with some parameters and basically automate the process of prompting the model. The next, let's say, step of interaction is by fine-tuning some of the hyperparameters. And what are these hyperparameters? For example, we can talk about the temperature, which basically controls a little bit. It's sort of a knob that controls how the randomness of the response provided by the model. And usually, let's say, a value of 0.2, it tends to be relatively deterministic in the approach and in the response that it gives. We can also, let's say, fine tune or tweak the max token parameter, which basically let us modify how many tokens our model is going to use to produce the response. But pay attention that this is the max token, at least in KNIME Analytics Platform. The value that you're going to put in there also includes the tokens in your prompt. So if you expect to have a rather verbose answer, try to increase that number. And also, this is maybe not so much, let's say, a user tunable hyperparameter, but a context window is also something that you need to keep in mind if you want to have, let's say, or customize your response. This, as I said, you would need to really retrain or fine tune the model to really modify the context window. But you see on the top, you have the option to choose which model, and each of these models basically has a different size of the context window. So you can basically just be smart about the choice of it, and then automatically include or expand the response that the model can produce. The next, let's say, most complex, interaction is what is called retrieval augmented generation. This is a very trendy, I would say, technique, and also rather powerful, that allows the user to provide more context to the LLM, so that the LLM can produce a fine-tuned response. And this fine-tuning response, it is not the fine-tuning of the model. So those are two different things. What we're trying to sort of ingrain in this case is more knowledge, more basically user-defined knowledge into the model, so that we can, for example, more easily fight hallucination in the model, or update the knowledge of the model by providing some more recent information. And usually, to do that, you see we need to have a knowledge base. It could be a combined knowledge base, for example, if it's used in a sort of business scenario. And you can include a knowledge base, different type of documents, right? It could be text, it could be images, it could be video, it could be anything that you think might be useful. There is usually a phase of loading, transformation, and most important, embedding. So we need to embed these resources, or we need to obtain a vector representation of those resources and load it in what's so-called vector store. We're gonna have a look a little bit more into details of which of these steps. And then, on the other hand, let's say the process, you have also the user prompt, right? That needs to be also in this case embedded, so that the vector store can run a similarity search and then retrieve the most, let's say, the most meaningful match for the model later on to let's say, to produce a more meaningful and informed response. Okay, so but what is it, an embedding model? First, let's break it down, the RAG process, into smaller steps. An embedding model, put it very simply, is a model that produces a vector representation of some initial input. In this case, we have a sentence. We pass it through an embedding model. We obtain a numeric representation, a vector. Okay, I mean, very, very simple. Now, if we look at a circle as our, let's say, as our space, our embedding space, we see that the first sentence, so the Oscar for Best Actress goes to, and Argentina wins the Soccer World Cup, they are rather distant in the embedding space, right? This already gives us an idea that these two sentences, but even by just looking at the space, are most likely not talking about the same topic. Okay, so now that we know how we can embed, so we need an embedding model to transform our text into vectors, we can store those documents, those numeric representation, in what is called vector store. Vector stores are basically databases, sort of special databases that are optimized for fast searches and fast similarity searches and matches. So you can see here in this table, we have different, let's say, text. Some are talking about, if you read about soccer, and some are actually about movies of the Oscar. And you can see that in a way, some of those vectors are sort of clustered in one area of the vector space, whereas the sentence about the Oscar is a bit, let's say, far away from the rest. And now, if we, as a user, ask who won the soccer World Cup, so this is a user prompt. This user prompt is embedded by the model, and then what does the vector store? The vector store runs a semantic search, a similarity search, and so the data you see in the space is where the embedded sentence would be sort of located, and therefore the retrieved documents out of the prompt would be roughly the ones that are closer, that have a most similar vector representation. So puts very, very simply, this is like doing sort of Control F on a big document, but providing sort of your input as a starting point. Okay. How does the interaction in a RAG happens? So we need to first, this is just, we are iterating the concept again. So we need to load our source, our data source, mostly our knowledge base. We load and transform, and most important, embed our resources, and we store them in our vector stores. For example, we're going to see that we're going to use a document that is sort of the bank knowledge, basically knowledge base. And this you can see maybe not so well here on the slide, but you will have it this PDF later on for the exercise. This is a document that contains the description of what the bank defines as investor agreement. So it's a knowledge base provided by the bank has that is not available, let's say, on the internet. So the model doesn't have knowledge of this. We can produce an embedding of this and store it in the vector store. Okay. At the same time, we're going to ask what are the types of investor agreements. So this is our user prompt. We're going to embed it and query the vector store that will be able to retrieve the most similar answer to our question. Okay, so this is the RAG interaction that we're going to be also building later on. And let's say the latest, or the last level of interaction would be that of conversational retrieval agents. We are not going to be, let's say, having a look today at this in practice, but I still wanted to mention, basically this conversational retrieval agents, they sort of act as smarter or advanced entities, sort of, that can enhance even further the capabilities of LLMs by having the option to choose which tool, if at all, is needed to answer or provide answer responses to the user in a custom way. So in a way, they are even smarter, right? If we RAG, we can customize the response, but we need to be very clear about what sources the model should use to provide a more complete and meaningful answer. With agents, the agent is sort of able to understand what are the tools, what are the vector store that we are using is most useful, most meaningful to provide the answer to the user. And let me also say that soon, I believe in July, roughly, we're going to have also the option to fine-tune the model. So this is coming up. It's still not available yet, but it will be there. How can we do then? So we had a better look a little bit at the theory in general, and how can we do a GenAI in KNIME? We have an extension. It's called the KNIME AI Extension, and with this extension, we can leverage LLMs in a low-code fashion, and we can basically leverage open source model that are accessible by API. By this, I mean, for example, the models provided by OpenAI, by Hugging Face, those are open source, or by Azure, or we can also leverage local open source model provided by GPT-4All. So we have quite a few options there. And with this extension, we have, of course, no to authenticate to the services. So for example, Azure, OpenAI, or Hugging Face, we have no to connect to the models that we want to use. For example, GPT 3.5 Turbo. We have models to connect to chat models. And we have nodes to connect to embeddings models. So we have basically connectors that allow us to use different models and different resources provided by these providers. And we also have options to create create vector stores and also agents. And I don't know if you can see from the slide, we also have a node to basically use DALL-E if you want to generate images, for example. So not only text, but also images. All right, this is a link that you can, or a webinar that our developer the extension ran last October. So if you're interested, you can follow the link and watch it again. But today, and now I would like to spend a few minutes describing what we're going to do today with the exercise. So the exercise is going to be, as we introduced at the beginning, is to detect frauds using statistical and visual techniques. And also then we are going to use GenAI to generate email alerts for our customers at risk. You need to obviously know that banks monitor the risk of fraud regularly, right? And if they identify a risk, they should at least take immediate action to notify their customers. So there's a bank A, identifies a potential fraud, and without AI, what would they do? Especially if they have a very broad customer base that maybe has or maybe speaks different languages or is located in different areas of the world. Well, usually before that, they maybe would use templates that were written and translated in different languages, but they were obviously limited to, the amount of language that the bank in that specific moment considered needed. And then at that point, they could fill the template and send it to the customer. This is possible, of course. They've been doing it for some time. I mean, before AI and GenAI, this was most likely the norm. The problem is with that, it is obviously slow. It could be, it's hard to customize in the sense that if you happen to have a customer that speaks a new language for which you don't have a template, what do? You need to take some time to finally realize a template, create a template. So you see this scalability of this process tends to be a little bit slow, and also it's very hard to parameterize and to automate. On the other hand, with AI, we are, let's say, freed from this burden in a sense. Let me just move a little bit here. Yeah. Okay. And and with AI, we can more easily customize and obtain basically alerts in multiple languages, what we're going to do today, and also customize it with specific information. And that's where we're going to use our vector stores to provide specific information into the email sent to the customer. By the way, for people who want to, especially they're online, you can, let me move a little bit. Okay, yeah. You can have the slides also for people that are on site. You can have the slide. You can access the slides at the URL that you see at the bottom. So you can also save the slides for yourself. All right. So let's break it down again. The problem: we're going to detect frauds and let GenAI create multiple alerts for affected clients. How are we going to do this? We're gonna access contracts like the one that Lada showed before, similar to those. They are PDF. They are so we're going to access those contracts, and at the same time, in parallel, we're going to access data about customers from a MySQL SQL database. So we're going to bring it together, and so we're going to do some fraud detection, right? We need to identify our outliers. I'm not sure if you can see this. Let me put it here. Yeah. Okay. Good. We're then gonna prompt our LLM to generate initially just sort of vanilla email alerts, and then we're gonna use the knowledge base to include more information, and finally basically generate those email alerts. All right, and that's how we're gonna have basically gonna break the task into 5 parts. Again, you see here, part A and B are going to be about detecting fraud in investment contract, and for that, we're going to use visual and statistical techniques. We're going to have then you guys prompt an LLM for a completion task, so where we ask the model to generate email alerts. In D, we're going to use a knowledge base, and that's going to be the description of this investment contract that the bank has internally, to enrich basically the responses. And finally, if we make it, that's optional, we're going to deploy a data app so this messages the data up on the KNIME Business app, which is a KNIME commercial, let's say, component. And today, of course, for you guys, it's going to be obviously provided for free. All right, let me go into more details. As I said, in the initial A and B task, we're going to detect frauds in investment contract by basically initially blending extracted contract with basically customer data from a database. We're going to prepare the data for visualization, and we're going to basically create a little dashboard that allows us to identify visually those outliers. And then after that, we're going to move to the statistical outlier detection. So we're going to use the numeric outlier node for that. And basically, we're going to then use that knowledge also later on in the downstream part. And you can see a little bit on the right-hand side of the slide how your solution should be looking like, but it's up to you to customize it as well. In C, we're going to be, as I said, prompt an LLM for the creation of for sort of vanilla creation of email alerts. We're going to be able to access, for people that are on site, for free OpenAI keys for that. You can select a model. You can play a little bit with different hyperparameters of the model, see what you get. You will have to engineer your prompt, of course, and provide it to the model. And we also would like you to visualize the output of the LLM. And in D, on the other hand, we're going to be taking a step further and use a knowledge base for customized email alerts. We're going to initially read a PDF that contains this bank-owned, basically, description of this investment contract. We're going to partition this document into smaller chunks to avoid, let's say, exhausting the context window of the model. We're going to create a vector store. We could then we're gonna then retrieve the parts that of the let's say of the document that we need with a prompt, of course. And finally, basically, we're going to bring it all together to perform a sort of a RAG process. And finally, in E, we're going to deploy our solution KNIME Business app. Let's see if we get there. The idea is that we are going to be able to see this solution as a web-based or browser-based application. Okay, so with that, I would conclude the streaming session for the people that join us online. If you join us online, you can find the material. I already posted it on the chat. But you also find the material on the KNIME Community Hub by just typing GenAI Learnathon, or by just following the tinyurl /KNIME-GenAI-exercises, or you can simply scan the QR code. And with that, I would thank very much the people that join us online, and I wish you the best with this exercise. Have fun, and let us know how this went.